So the first part of this question tells us to differentiate with respect to x, given that y is equal to 2 root x over 1 minus x. And we're expected to get x plus 1 over root x times 1 minus x squared. So the first thing we have to do is identify the rule we're going to use. So we have a fraction, and we have values of x in the numerator and denominator, so this suggests that we're going to be using the quotient rule. So the quotient rule states that for y is equal to f of x over g of x, then dy over dx is equal to the derivative of f of x times g of x minus the derivative of g of x times f of x over g of x all squared. So it's important to remember the order in the numerator because there's a subtraction instead of an addition sign. So unlike the product rule where the order doesn't matter, you have to remember this order. The way I think of it is that you differentiate the function that comes first and f comes before g. So we know that f of x, in this case, is equal to 2 root x, which is equal to 2x to the power of half. So the derivative of f of x is equal to x to the power of negative half, which is equal to 1 over root x. Now, g of x is a lot easier to do, so we have 1 minus x, which differentiates to just negative 1. Substituting these values all in, we get 1 over root x times, let me just write dy over dx, 1 over root x times 1 minus x minus negative 1 times 2 root x over 1 minus x squared, which is equal to 1 minus x over root x plus 2 root x over 1 minus x squared, which if we make the numerator a common denominator, we get 1 minus x plus 2 root x times root x all over root x all over 1 minus x squared, which is equal to, so this becomes 2x. So we get 1 plus x over root x, because when we divide by fractions, this goes to the denominator, times x, 1 minus x squared, as required. Always good to end with something like that when we have a show that question. And that matches this, so we're correct for this first part. Now we have question B, which asks us to find what values of x satisfy dy over dx is equal to 0. So when we have dy over dx is equal to 0, that means the numerator has to equal 0, because 0 divided by anything is still 0, as long as the denominator is not 0. So 1 plus x, therefore, we're going to equate to 0. So x has to equal negative 1 by simple algebra. However, it's useful also to check with the denominator what our result is. And lo and behold, when we put it into the denominator, we see that this doesn't actually work, because we've got a square root in here, and anything in a square root does not work for real numbers. It gives us a square root of negative 1, which is actually I, and an imaginary number. And since they want real solutions, the answer to this question is never, as this solution is wrong. So for question 2, we're trying to see if it's undefined. So actually this is, no solutions. So for question 2, we're trying to see when it's undefined. Essentially, undefined is anything that's divided by 0. So this time we're going to be equating root x over 1 minus x squared to 0. And we get x is equal to 0 or 1. However, it's also worth considering that undefined would also count values that actually don't have any real solutions. And we have a square root in there. So if we manage to make this a negative value, then we've also got an undefined value. So therefore, we have a range for this part, for the x equals 0 segment. It actually becomes x is less than or equal to 0. And then we have x is equal to 1. Because this part over here is linked to this part. And anything, the square root of any negative number is undefined. So therefore, this is the solution for this part.